All right, well, the basic arithmetic operation is addition. So we might ask the question, what are we actually doing when we add? In order to do that, we have to consider the definition, and there's actually two slightly different definitions of what addition is. The first one we'll look at comes from a set of axioms proposed by a late 19th, early 20th century mathematician by the name of Giuseppe Peano. And the Peano definition of addition is based on the idea of a set of ordinal numbers. That's to say, there's a set where there's a definite ordering of the elements. Given any two elements, A and B, we have some way of being able to say this element is first, this element is less, and this other element is later, it's greater, it's larger, some means of making that comparison. Now, this property isn't limited to the set of whole numbers. Other properties of their sets have this property. For example, the letters of the alphabet. If I have two letters of the alphabet, K and R, for example, then we have a clearly defined ordering that says K comes before R, and it makes sense in that context. Once I have that ordering, I'm actually in a position to be able to define what the natural numbers are. So let's consider the set N of all the natural numbers. And the elements of this set satisfy a couple of important properties, and the two that are important are part of the Peano axioms, and they are these. Every element of this set of natural numbers, every number, has something we'll call a successor, and we have various ways of designating that, but the most common is to use this A star notation. Now, while it's true that every element A, every natural number, has a successor, it's not true that every natural number is the successor of something. And in fact, the second import of the Peano postulates for us is that the element that we call 1 is not the successor of anything. There is no natural number whose successor is 1. Now, between these two postulates, we actually have a way of defining all of our natural numbers. So let's have a go at that. So first off, the thing to note here is that the number 1 is somewhat unusual. It is not the successor of any element. So if we want to find a starting place, 1 seems to be a very good place to start because there's something very unusual about this number 1. Now, we could say that informally we might say something like 1 is the first element. There is nothing that comes before 1. Now, look at our first postulate. Our first postulate says that everything has a successor, and in particular that says that 1 has a successor, which we'll use our 1 star notation for. So there is a thing that comes after 1, but we can apply that first postulate repeatedly. This 1 star, the successor of 1, itself has a successor, which will designate the successor of 1 star. 1 star star. And we can continue this for the successor of the successor of the successor of 1, and the successor of 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 1. And we can do this as much as we want to, but then at some point we get lost in all of these successor ofs. So let's make our lives a little bit easier and invent a name for this thing that exists, this successor of 1. So I'm going to cast about and think, what would make a good name for the thing that follows 1? And how about 2? We'll call it 2, and we'll invent this symbol 2, and that is the symbol that we use for the word 2, which is the successor of 1. And likewise, since 2 is a natural number, it has a successor, and I can designate that successor, again, using the star notation 2 star. This is the thing after 2, and I can come up with a name for that. How about 3? Sounds good, and we'll write this symbol for that number 3. And again, so since 3 is a natural number, there's a successor to 3, which will designate 3 star, and we can either call it 3 star, or we could come up with a new name for it. And again, we'll come up with the name 4, and we'll have that symbol for 4. And it turns out this is all we need to define addition. So let's go to the piano definition of addition. And there are two parts to this addition. And the first part is this definition that n plus 1 is going to be defined to be n star. Now, if you remember what the notation means, what that tells you is that n plus 1 is defined to be the number after n. It is the successor of n, and we have successfully defined the first addition. However, if we want to add something else, n plus 5, n plus 7, we have to include a new line of that definition, and that's going to be the following. N plus k star is equal to n plus k star. And again, let's take that notation apart. What that means is n plus the successor of k, the number after k, is the same thing as the number after n plus k. And this actually allows us to define and find every possible addition that we can with the natural numbers. And next time, we'll take a look at an example.